Is Earth a unique planet? When we study the planets of our solar system, often we overlook the Earth. Planet Earth, it's a very unique planet in our solar system, and despite our approximate location on top of it, this planet still bears so many secrets for us about itself. The planet Earth in our solar system, so far as we know, the only planet can support life on it. It's rich with the beautiful oceans, thick atmosphere rich on oxygen, and a strong magnetic field protecting the life from distracted forces of cosmic and solar energy. Let's talk about our planet Earth as a planet in the solar system and find out what is so unique about this planet and why she could home all us, the variety of the life on it, and the amazing landscape. Comparing with other planets, Earth is the one of the 4 terrestrial planets. Those that are rocky planets, we call them in astronomy. And it's also the 5th largest planet overall in our planet system. We know the intriguing shape of our planet. I had a previous video about that, you can learn in detail. Although it's common to understand that it's spheric, we know it's slightly flattened at the poles and bulgy at the equator. And it's all due to the forces of rotation of our Earth around itself. Therefore, the furthest point on our planet from its center is located in Ecuador, rather than in Himalaya, like you would think. We know that the density of our planet is quite high, 5.52 gram per cubic centimeter, and its circumference about 40,000 kilometers. Let's talk about some astronomical properties of our planet, which are determine the particular seasons on our planet, day, night, and all the cycles which we observe. First of all, we know that Earth rotates approximately 24 hours around its own axis. Although the true length of the solar day is slightly varies, we custom for that. Thus, the sun rising up over the horizon and setting down is slightly different than the rotation of the planet around itself. Therefore, we have this slight difference of days, and we accounted for this extra time every year into the leap day once in the 4 years. Orbit of the Earth is eccentric, elliptical one, and it's as well affecting our seasons on the planet. The Earth rotates around the Sun every 365.3 days. We know that in the summer, the northern hemisphere receives the most direct sunlight during the summer months, resulting in the hotter temperatures on the planet. While during the winter, it's the coldest months, because the sun rays have further to go reach the Earth's surface. We have reversed seasons in the southern hemisphere. However, the position of the oceans in the continents different from northern in comparison with the southern hemisphere, affecting the heating of the oceans, heat distribution, cooling of the planet, and therefore we have such a different seasons, comparing northern and southern winters and summers. Another very important fact about our planet is about its axial tilt. It's about 23.4 degrees, meaning that the northern and southern hemisphere are exposed to the sun at the different times. And that's how we have the 4 seasons. You know, in some places 4 seasons are more pronounced, and some seasons they smoothed by the proximity to the ocean or the sea. One of the most important and intriguing characteristics of our planet is the presence of the satellite, the Moon. Although many other planets in our solar system have moons, even several, our Moon is very unique, and we have a specific relationship with the Moon, and it has the measurable effect on everything from our climate to the length of our year. Scientists say that the Moon is kinda tidally locked to the Earth. It has a rotational period that the same length as it takes to orbit our planet, and it's mean that we're always observing the same side of the Moon facing towards us. And before people fly into the space and move the spacecraft around the Moon, we didn't know what's happening on the other side of the Moon. It was a mystery. The Moon is moving away from us at the rate of 38 millimeters per year, so the space between us and the Moon increasing. But however, if you think the tides solely depends on Moon, it's not true. We have a complex relationship between Moon, Sun, and the Earth's rotation. Yes, Sun plays a big role. It's quite proximate to us, and it's so big it has huge gravity pull, so it's affect the Moon pull and affect our life on the planet. Many scientists suggested that not only the rise and fall of the tides caused by these interactions, which actually not only happening in the water, we just observe it very nicely in the water, it's also happening in the crust of the Earth, the lithosphere, the solid crust. But also this interaction keeping the Earth's tilt stable. Thus, for example, if we didn't have this Sun, Moon and Earth triangle, probably the tilt of the Earth will move from million years to million years and have some kind of chaotic changes. Because of the size of our planet, its composition, density, we know that our planet have a good gravity pull, preserving our atmosphere, heterosphere, or the oceans, and ensuring the life on our planet. We know that average we have about 9.81 meters per second acceleration of freely falling objects close to the Earth, like Newton discovered on example of the apple. However, these gravitational forces are slightly different across the planet. At the equator it's slightly lower, 9.78 meters per second, and towards the poles a little bit more, 9.83 meters. Similar if you're going higher into the mountains, for example at the top of Mount Everest, about 8.8 kilometers height, you will weigh about 0.3% less than you will weigh at the sea level. And the more you're traveling into the higher levels of the atmosphere and outside of the orbit of our planet, this pull will decreasing. Thus, scientists suggested that the Sun's is so large in its gravitational pull, it's the half those of the Moon, despite its distance from the Earth. Therefore, at the first and the third quarter moons, the Sun and Moon are in opposition and produce neap tides, which are lower by its amplitude. And the higher amplitude tides are produced during the times of the new moon and the full moon. Now you know why you're so affected by those times of the months. In my numerous previous videos, we talked about the formation of the solar system, where we discover how the Earth was formed. We learn about interior of the planet, some particular geological features, composition of this planet. We'll just briefly go through that, and I will say that our Earth is composed of the core within, metal, mantle, crust and atmosphere. Some also suggested we have a biosphere, all the life forms that in a thin layer of lithosphere and atmosphere close to the Earth. It's interesting, the Earth is quite different just because we have inner and outer core. Inner core is solid and the most heavier, and the outer core is liquid. And they both mostly contain iron and nickel, very heavy metals. It's very hot, 6.7 degrees in Celsius in the center, and the heat is produced there by radioactive decay, and 20% of the energy comes by gravitational binding of the planet. We know that the planet in its just formation was much hotter, and now it's slowly cooling down. This cooling down causing this process on its lithosphere, the surface. Volcanic eruption, spreading mid-oceanic ridges, and the formation of our crust on the surface, which we observe right now. Our planet as a solar system produced from the explosion of the nebula, so we are built from the remnants of previous solar systems and stars. And majority of the minerals composition on our planet is so numerous, all different elements. However, 99% composed only from 8 elements, such as iron, oxygen, silicon, magnesium, sulfur, nickel, calcium, and aluminium. This is the most common elements you will find on our planet. We know that our planet, during its formation, experienced a fact. Very important one, it's when the moon actually crashed to our Earth. There's numerous theories when and how it happened. However, we know there was a fact, and we still experience right now on the surface of our planet. There's also numerous asteroids, comets, and other objects that passing by bring water and other elements on our surface, and some even suggested they might bring the life. We know about the initial atmosphere, how it's formed. Watch my video about the first atmosphere on our planet. And we know that today the atmosphere composition about 78% of nitrogen, 21% oxygen, and some other elements. This is so important for us because this is most comfortable for us to breathe and stay alive. We have the layer of ozone that blocks ultraviolet radiation from the sun, and it's also creating this kind of greenhouse effect. Greenhouse, it's like when you cover with a glass jar your little tomato, creating local heat. heat waves coming through the glass, but they're not escaping as easy. That helps to sustain the life on our planet. However, we know that it's so sensitive and intricate system. If it's too much greenhouse affected, you might kill the life. If it's not enough, you might kill it from overcooling. Therefore, our planet's just perfect for today for us to strive. And the atmosphere and all these properties are all possible due to the layer of magnetic field, upper layer of our atmosphere. It's protected the gases in the atmosphere from being shared away and carried off into the space by solar wind. And our magnetic field around our planet protect us from destructive action of radioactive particles coming from the sun all the time and from the cosmic deep space. One of the most important and distinctive about our planets is that we have plate tectonics. It's ensure we have these two different cores on our planet, oceanic, covered with the ocean mostly, and continental. We have the movement of these plates constantly through its history, changing the climate, changing the regional geology, changing the regional geography, changing the life adaptation. Also, we have opportunity to build the tall mountains and create the ice caps. All that is due to the plate tectonics and all these interactions between interior of the planet, gravitational pull of the sun and the moon, and the cooling of the planet with time. Therefore, we have such a big diversity of geographical features on the surface of our planet. We have volcanoes, rift zones, deep trenches in the ocean, flat areas, deserts, rainforests, beautiful oceans and seas with the coral reefs, and the numerous ice caps, which preserve the fresh water for us. If you only look at how many different places you can find on our planet, how colorful and diverse they are, you'll be amazed. So far in our solar system, we don't observe anything like that and that variety on any of other planets. Thus, if you have some kind of alien arriving to our planet, what you will show to them? You will show the beautiful and the most largest rainforest in Amazonia. You will show the most biggest and active in terms of volume and area volcano in Hawaii. You will show the biggest crater that preserved right now on the surface, about 300 kilometers in diameter, located in South Africa near Johannesburg. We will go take these aliens to see the deepest canyon in Tibet, which reach up to 6 kilometers in depth. You will show the tallest waterfall situated in Venezuela, Angel Falls, standing almost up to 1 kilometer of the uninterrupted waterfall on our planet. Of course, you're going to show the biggest ice sheet in East Antarctic, the largest glacier, Antarctica Lambert Glacier, more than 100 kilometers wide and as deep as 2.5 kilometers down. And of course, our visitors will see themselves the highest peak on our planet, Everest. Although there's features around within our solar system which are higher, bigger, for example on the Mars we have much higher volcano up to 30 kilometers, bigger craters on other planets and so on. However, it's amazing that we can find it here on our planet on such a small area. So why it's there life is possible on our Earth and why it's there right now? Everything I just talked about, its astronomical position, size, rotation, interaction with the sun and the moon, other planets, the way how the planet was formed, its interior, its magnetic field, the plate tectonics on the surface, particular gases composition of the atmosphere, its preservation due to the magnetic field size and so on of our planet, and of course the position towards the sun, which is, although the most given in our solar system of the terms of energy and heat, to everything in our solar system, therefore could be the most destructive. Putting all this together, our planet astronomical properties ensure that the life could not just develop on our planet, but also survive through millions, even billions of years and strive. Astronomers called this position in the solar system, in any star system, the Goldilocks zone, the place, the distance from the main star, which is capable of retaining water with atmosphere and therefore potentially can have a life on it. All known forms of the life require liquid water, so it's the main standard for finding life on other planets. But the planets need just more than the water. For example, we have other planets which have plenty of water. We don't observe any particular life striving there. Earth just have right amount of reasons to have a life on it. Atmosphere is the first, required oxygen-rich air, so you must have a particular magnetic field to sustain and preserve those light molecules of the oxygen. For example, if we didn't have atmosphere right now, our average temperature on our surface of the planet will be minus 18 degrees. Today, just because we have the beautiful atmosphere, it's plus 15. And thanks to our gravity and magnetic field, we do have it on our planet. Sun, very important factor, its distance from it, just amount to preserve the life on our surface. Sun is also a very important factor. We need to have perfect distance for this temperature and heat levels. Sunlight is very important. We can have too much sunlight or not enough, like on other planets in our system. And one of the important things which we shouldn't forget about our planet, that we have the water cycle. Water cycle is this exchange of the water between hydrosphere, oceans, and all the water bodies on the surface, soils and forests, into the atmosphere, and then coming back on the surface of the Earth. You would say, oh, we just discovered the water on the Mars as well. It's there. Why there's no striving life? It's very important how you find the water. It should be in a liquid, gas, in a solid form. And as I said, for example, plate tectonics ensuring preservation of the water in the ice caps. It's ensuring the water cycle, moving of the water throughout, and constantly supplying all the life, plants and animals, with the fresh water all the time. We are humans, composed of 70% of the water. We need that water to be available to us all the time. Our planet is breathing, it's alive. It might have all those components and elements, but it could be dead, with no life. Our planet is alive, plates are moving, lithosphere is very active, volcanoes erupting, water's flowing, glaciers melting and freezing again, and the life striving because of that. Let's don't underestimate our planet, how providing she is for us and how giving and supporting our planet for us. And before we rush to any other planets, establishing colonies there, polluting our planet and forgetting about our own home, let's first ensure that our planet can continue being alive and continue giving and supporting our precious life on its surface for next not just millions but also billions of years.